Good morning, class. Good morning. My name is Hawa Umar. I'm here to talk about detection of radioactive radiation. Different types of devices have been used to develop detection of radioactive radiation. These are the Geiger molar counter, scintillation counter, and the diffusion chamber cloud. But the most commonly used one is the Geiger molar counter, so let's talk about it. The Geiger molar counter depends on the ionization of radioaction on gases. The electrons consist of two metals, usually sealed and filled in with a gas, and they contain argon, usually with a low pressure. The pressure produces their drift to the positive ions, while the positive ions migrate to the negative ions, usually with a small current known as a pulse current. Thank you. As I said, this is Geiger molar counter. So this is the argon vapor with a small amount of remains. This side is the negative electron, while this side is the positive electron. The negative electron and the positive electron join together to make the ionization chamber.
Morning, class. My name is Abbasolom Manasa, and I'm here to present on the topic of transmutation. I start by when a certain quantity of radioactive material disintegrates spontaneously, the word decay is used. The disintegration of the elements emits alpha particles and beta particles, and sometimes gamma rays are accompanied to emit for the radiations. So, atomic transmutation, when the element is bombarded, it forms new different elements, and the process is called atomic transmutation. In 1919, Rutherford succeeded a nitrogen isotope, turning it into an oxygen isotope by this equation. This is represented by this equation, and many atomic particles can be used to bombard like neutrons, protons, deuterons, and alpha particles. The light elements can be bombarded to form new different elements, which is represented by the equation here. The second equation here. And when the isotope is heavy, it forms a completely new different isotope, which is represented by the equation I want to use. In our modern day world today, new elements are being produced by atomic transmutation by the process of neutron bombardment. The alpha particles that is the most effective is the neutrons, because it has heavy charged particles, and most elements today have been produced by atomic transmutation, called like curium, lawrencium, and plutonium today. For example, sodium 24 was produced from sodium 23 by neutron bombardment. And in our modern day world today, we have elements like phosphorus 30 today that can be used in our industries and medicals and research institutes. Thank you.
The diagram of which was one of the first instruments used to detect radiation around 1895 by Planck.
Okay, so is that the only instrument?
No, we have other instruments like this. By this, since the This is the scintillation counter.
Good.
And the diffusion cloud chamber. Yes, the diffusion cloud chamber is used in detecting individual alpha and beta particles which go through condensation of water vapor.
That's very good. All right, thank you. Now you have said something. Okay, are you done?
Yes, sir.
Okay, questions for them? No. In fact, I must confess, their presentation is okay. Among others, the final result will be out, though marking is going to be based on individual performance per group. So, in that case, if you see your team member or group member having more scores than you, know that that person did well towards his or her own part in that group. So it is individual now. So the total performance of a group is going to be the total score of each member of that group, and that is what will make a group to be the best. So like I said earlier, make sure your team members do well. Okay, so I have two questions for you since the audience don't have. Okay, let me start from detection of radioactive radiation. If somebody has his body or her body exposed to radiation, how can we detect? Madam, please leave that please. Thank you. What can we do to detect radiation? If somebody is exposed to radiation, how can we know that that person is exposed to radiation? How can we know?
I think by using the scintillation counter.
We can know by the use of the scintillation.
By the use of
Scintillation.
okay. So do you have any working principle of the scintillation counter? So we are going to carry the patient and choke inside the counter.
No.
So how do we detect?
Scintillation counter is mainly used to trap light and radiation. So it's the best instrument.
Okay, so is it used in the hospital? Can it be used in the hospital to detect radiation?
Yes.
Okay. All right. Then last question. You talked about atomic transmutation. So this atomic transmutation is used to produce what? The atomic transmutation is used to produce what?
The atomic transmutation really depends on what you want to produce. Like light elements produce new completely different elements. That's and heavy elements and heavy isotopes they produce an isotope of the original element that has been produced.
So that's a very good. So thank you very much. You can clap for me.